Hello everyone, and thanks for joining the webinar. Today we will have a look at Geo Digital Twin and openBIM for the digitalization of infrastructure assets and extensive estates of public administrations and private managers. In particular, we will focus on the success story of MUIF, Single Railway Infrastructural Model, in RFI, Rete Ferroviaria Italiana. Let's introduce the topic of BIM and GIS integration based on open standards, hearing directly from Aidan Mercier from buildingSMART International, who will present technology trends and standardization strategies for creating Geo Digital Twins.
Hello, thank you very much for having me, and thank you for your attention. My name is Aidan Mercier, I'm the Marketing Director of buildingSMART International. And you'll see here on the screen that buildingSMART International supports a variety of standards and services under the umbrella of openBIM. I'm going to talk to you a little bit about some of the radical steps being made and the advances in BIM and GIS integration, and talk to you a little bit about why now is an important time. So indeed, this question, BIM and GIS, why now? Well, even if I look back through my career, when I began in a software organization focused on geospatial workflows for linear infrastructure, and if I fast forward to where I focus on openBIM and the AC industry, I've often wondered why this integration has taken longer than it should have done. There's clearly a natural synergy between vertical and horizontal infrastructure, and of course when we think about anything within the AEC industry, there's always a georeferencing component of that, and I've never quite understood why that's the case. However, in this presentation and some of the things you'll see later, there seems to be a radical shift in how we focus on this and the approach that we're taking through openBIM and some GIS workflows. As I mentioned, at buildingSMART International, we're an industry body supporting the built environment through more sustainable and less expensive buildings and infrastructure. A lot of the work that we do is done through domains, and we collect user requirements and develop standards and services. As some of the things we hope to see in the future are better decision making through more automated efficiencies and more sort of future state technology supporting that. We believe that the industry should be enabled by data fusion via open data standards and services that we can create, and also partner with various organizations to help to do that. If we move forward into the future, then we can fully understand that workflows will be driven by different sets of APIs and technologies to support that. And of course, we're very much at this inflection point where we believe that this is a radical shift happening. One of the radical things that did happen at buildingSMART International was the launch of IFC 4.3. Many of you will know that the IFC, the Industry Foundation Classes, is our flagship standard, which was approved by ISO. But this historically always covered buildings and the support for the workflows around IFC 2x3. IFC 4.3 was again a radical shift to really consider infrastructure domains. With that came a lot of technical challenges to think about, such as alignment curves and all the other things that were required to support that. But we have a growing list of software vendors that support not only the outputs and the standard itself, but also a growing number of clients and AEC firms that really believe that this is a first-class standard that will surely soon become an ISO standard moving forward. So this was a major step and a few years in the making for sure. But this really allowed buildingSMART to focus on some of the linear infrastructure as well, to support georeferencing. And if we consider what buildingSMART's partnership network looks like, the reason I share this slide is actually throughout the years we've been developing a close relationship with OGC, developed a partnership with the World Geospatial Industry Council, most recently with Geospatial World, to really advance the conversation and use cases and the development of requirements to consider all things BIM and geospatial. A lot of this work is done in our domains. You'll notice here that we have a new domain in maritime. We do expect future domains to come forward. And one of the things that always comes out of this is there is now a BIM and GIS component to it. So user requirements are starting to push from bottom up, and with the support from software vendors, and clients also helping to drive this, we believe that this will have a major impact on the industry moving forward. Then if you look at some of the top-down approach, we've noticed around the world that there are more IFC and BIM mandates moving forward. So in our sphere of what we do at buildingSMART, we see this as a very important thing. IFC is the core component to help exchange information, to make sure that data can be interoperable, and that openBIM is actually the heart of some mandates that we see around the world so that projects can benefit from that. We've also noticed a rise in software vendors supporting openBIM workflows, and of course this bottom-up and top-down approach is really paying dividends. One of the radical things that we also launched this year was our strategic roadmap. If we consider today where we are with current standards and where we'd like to get to, we believe things like linking and extending data standards with our latest IDS and the BSDD invalidation service will help us cross this chasm into the next generation of data standards such as IFC5 and future interface standards, as well as automated simulations. So if we consider there might be an evolving industry of digital twins enabled by standards and services, a lot of the things on this roadmap help us to see that future. What is interesting about how we put the geospatial context to that, well, I said it earlier that actually everything within the BIM world has a location as associated with it. When you think about some of the radical advances in GPS and camera technology for things like photogrammetry, then we can start to envisage how BIM and GIS workflows will really improve the lives of stakeholders and end users that would consume this type of information. In our strategic working groups, I'll just highlight that we have had a BIM and GIS conversion group working for quite some years in developing a lot of this work, focused on some use cases and how we might align things like IFC, City GML and Land Infra. And we partnered with OGC on this and continue to lead a working group in this area. So we clearly see this as a huge priority, and this has been some work for many years around this topic. I'm also reminded that actually this year I was very much struck, and the idea stuck with me actually, and it was Michelangelo Cianciulli at our summit in Rome who actually brought that idea to my head, which was there are incremental innovations and radical innovations. Incremental innovations happen continuously throughout our work life. We maybe don't notice them day to day, but probably over the period of a certain period of time, we might look back and say, wow, can't believe we used to do that. I might cite an example that I went to an oil and gas event in, I think about 2011, and at the time they were saying absolutely no way that they're going to move to cloud technology. Fast forward 5 years, the whole conference was about cloud technology, because although that's a radical innovation, the idea was the incremental changes happened and then they became reliant on that new technical capability. So apologies for taking that, but this radical idea that the ACCA software talked about really stuck with me, that actually in this area of BIM and GIS integration, when we think about things like BIM and GIS digital twins and that connection between the two data sources, there is now a genuine opportunity for us to make use of that BIM and GIS integration. Let's not just say it as words, let's actually see it in practice. Again, from Guido Cianciulli, intelligent integration between existing technologies often leads to radical innovations. So sorry for taking your phrase, but for me it's been very important. I also talked a bit about AECO projects are spatial, and at the same conference we had Mark Goldman, who's also speaking today, talk about location and how it matters within AECO projects. So Mark has been a great advocate for this, and I think he's really helped to push Esri into the BIM community. And when we think about BIM and GIS integration, we've needed something from the geospatial industry to come in and help support those workflows. And I'm really delighted that they have been providing IFC support to the community. And I think what is important is Esri and their platforms become available for all software vendors to support those workflows, so that clients, rail and road operators and governments can have confidence that the systems and the technologies they use are based on open principles and open data sharing, and at the heart of it, software vendors that want to collaborate. We've got plenty of examples within our brochure, awards brochure. But I think at buildingSMART International, it really is an exciting time. I would like to say thank you to everybody who's taken some time to have a think about it. Let's consider this a radical shift, and apologies if I've taken or stolen any thunder from future presentations that might come forward, but maybe we can reinforce this message and support some of this work that is being done to really understand that there is a radical change happening. So thank you very much, and I look forward to speaking to you all soon.
Thanks, Aidan. I would like now to hand over to Mark Goldman from Esri, which will show us the importance of GIS and openBIM integration from the point of view of the GIS.
Hello, and thank you for inviting me to participate in the webinar today. I'm Mark Goldman. I'm the AEC Industry Solutions Director at Esri, and today I'll be sharing our perspective on combining openBIM with GIS. As it pertains to GIS and the use of BIM, there's perhaps some misconceptions or some older understandings of what GIS is. Most people understand GIS to be a mapping solution, but it's much, much more than that. It's a suite of mobile applications for doing field data collection. It's the ability to do spatial analytics and deep data science across many types of data sets. It includes imagery, remote sensing, visualizing and analyzing information in real time from various sensors. It certainly is more than just 2D these days. 3D, certainly BIM, included with 3D maps and terrain, provide amazing visualization and analytics capabilities. It's a data management platform for understanding data of various types, including BIM, including GIS, including IoT sensors and imagery, like I've mentioned. And in the case at Esri, it's a suite of developer capabilities, APIs that allow you to take our base applications and our base capabilities and extend them in many ways, and we'll get into that today. Well, BIM integration within the Esri suite of products, the ArcGIS solutions, goes back many years. As far back as 2015 with our flagship product ArcGIS Pro, where we started bringing in BIM data into the Geo database, created the concept of a scene layer package. In 2017, we formed an alliance partnership with Autodesk, which really opened the door for us to extend the capabilities of our GIS platform by adding Revit integration. A couple of years later, we extended ArcGIS building scene layer to include many different types of information that were specific to BIM and AEC workflows. Around 2020, ArcGIS Pro had an integration with the BIM cloud connection that Autodesk provides. And then around the same year, we extended our capabilities of ArcGIS Pro to have civil 3D integrations. Now, as it pertains to IFC integration, going back about 3 years now, in ArcGIS Pro, we began our deep integration with IFC capabilities. We launched a product about 2 years ago called ArcGIS GeoBIM that also brings in IFC as well as has a deep integration with Autodesk Construction Cloud and BIM 360. And over the last year and a half to 2 years, we have been including IFC 4.x integration all the way up to the latest 4.3 versions that have recently been approved by ISO. So ArcGIS Pro, this, like I mentioned, is our flagship product. Any architect, engineer, construction professional who's working with CAD applications, imagery information, needing to visualize data, needing to edit and analyze information, a wide range of data, should have a copy of ArcGIS Pro sitting right next to their CAD and BIM solutions. The workflow is typically to create models, create scenes, create environments in the desktop application, and then share that work with the world through online environments like you're seeing on screen right now. ArcGIS GeoBIM, I mentioned this a little while ago. This was released about 2 years ago. This brings together the Autodesk Construction Cloud with the ArcGIS Online and Enterprise environment. So in a single desktop, you're combining the large-scale view of GIS with the more detailed view of BIM, in this case with Autodesk Construction Cloud. And we have another application called ArcGIS City Engine, really one of my favorite products from Esri, which is a procedural modeling application. 3D entire cities are created through parametrics, large-scale urban layouts, and entire city layouts dynamically generated through parametrics. A computer-generated architecture capability enables the kind of environments you're seeing on screen, and we have IFC 2.3 export in that application. So why in the world of AEC should GIS matter? Well, GIS is all about location. And certainly in the world of AEC, where projects are spatial, location matters. Location acts as an integrator, a connector. It brings together the many types of massive data sets that are used in AEC workflow. Location acts as this common denominator and connector of AEC data. And when you're able to connect data in a single application, viewing CAD and BIM and demographics information and weather patterns and traffic flows, when you're able to bring all this information together that typically exists on different people's desktops, you're actually able to connect people in a way that enables digital transformation. And I would argue that digital transformation is critical for effective AEC project delivery today. The integration of data, the integration of apps is happening. It is required for effective project delivery, and digital transformation is happening in this industry. In fact, I would go so far as to say there is rapid progress in the world of architecture, engineering, and construction. Gone are the days where we're a little embarrassed about not adopting technology as fast as other industries. And I would say that AEC industry is in fact leading the charge with the adoption of technology. And with that, let me show you some examples of our integrations of combining openBIM with GIS. What I'll be showing you is a series of examples running in a story in an application called ArcGIS Story Maps from Esri. So here we're starting out with a map-like view, a satellite image view of the San Francisco Bay Area, and this is a dynamic real-time map. I can zoom in to an area on the peninsula in San Francisco. We add a layer of 3D information in the form of OpenStreetMaps data, the 3D information, including stadiums, roadway, buildings, elevation, etc. Now in this case, we created a model in Autodesk InfraWorks. We exported it to IFC 4.3, and then we imported it using the tools that come with ArcGIS Pro, our data interoperability tools. We can change our view, change our level of detail of our trees to be more detailed, and we start to see the bridge in context. Turn off a few layers, change some transparency, and you can actually see the individual objects that make up this bridge with the properties that began in a BIM modeling, BIM authoring tool in this visualized environment right here. And again, this is a dynamic view. This is a real 3D map. This is not just a static image. Here's another example, similar workflow. Again, OpenStreetMaps 3D content combined with a basic topographic map of Columbus, Ohio. And this is the satellite imagery and the architecture from 2009. The city undertook a riverfront development program where you can see the same information. The river is a little bit lower and a little bit of development has occurred at the riverfront in this 2015 image. And here we see a 2021 view with a proposed bridge in place, again in this 3D environment in this story map. So we added the bridge to the scene in a similar way that I described a moment ago, started out in InfraWorks, exported the model as an IMX file that came into Civil 3D, and then from there exported it to an IFC into ArcGIS Pro. And again, these objects maintain their properties, the parameters, the attributes that began, here you can see IFC 4.3, in the modeling application itself, maintained and made available for GIS capabilities. Again, change our camera angle, change our transparency, turn on and off some objects, and you can see all the way down to these structural elements, all the properties that you would expect to see in a BIM authoring tool maintained and brought over for GIS purposes. Another application generates IFC files, a company called iStram. This was a model that I came across about a week before the buildingSMART Summit in Rome last year. So I reached out to the modeling company, iStram, asked for a model they could share with me. And again, similar to what you saw in the other environments, this 3D model has GIS information, has BIM information, has OpenStreetMap data. Here's the same view in a BIM viewer, and here's the view in a GIS viewer. all the geometry, all the non-graphic properties, they're all intact, ready to be used for various location-based workflows. So here I select on the handrail, we can see it's a railing, and again, we see the source of the information, we see the IFC data. Again, it's 4.3. This was release candidate 4 from last year. All these properties available for BIM and GIS workflows. Another company, Vectorworks, exported to us multiple IFC files, the architectural wrap of a building, isolate it down to just the objects that I'm interested in, change my view, turn off the shell of the building, isolate just the structural elements, do the same thing down to just the mechanical system. And as we saw with the infrastructure objects, the model objects in this GIS environment, this is 2.3 content, is maintained in this GIS view. Bentley as well. Here we have a combination of tunnel and road information in a city environment. We turn off most of the information, make it transparent. We knew where in Sydney, Australia this was. We knew it's easting and northing, so we were able to place the project. And again, this view is interactive. It is real-time 3D model objects that we can change our view, we can change our perspective, we can turn on and off objects, and again, we see the BIM properties that came over as IFC content brought in to ArcGIS Pro and saved as this web scene. This is an interesting project. This is a company called CSPFEA. I met them actually in Rome at the summit, asked them to provide me a model of one of their bridges. This was an IFC 4.0 file. And again, just another example of infrastructure content exported to IFC, brought into ArcGIS Pro, and then saved as a web scene. And you can see again, in this 3D environment with terrain and buildings and the model objects themselves, the properties of those objects are available in a GIS view for BIM workflows. And finally, I don't want to steal the thunder of our friends at ACCA Software, but they have got some of the most impressive capabilities as it pertains to IFC, BIM content, GIS, brought together. I've just taken a couple of examples they shared with me, sped them up, put them into this little video, but I'm going to let my friends at ACCA take it from here. Thank you so much for the opportunity to present and share and talk about openBIM and GIS at Esri. Thank you. Bye.
Thank you, Mark. I would now like to give you a more detailed overview of the ACCA technology for openBIM and GIS integration. As BIM Geo Twin, GIS Digital Twin is the technology from ACCA Software for the openBIM and GIS integration. It allows to view, analyze and manage all construction data around the world in a single digital twin with the power of IFC, openBIM and GIS. Technically speaking, it is a dynamic connection between ArcGIS platform from Esri and ASBIM platform from ACCA. It is based 100% on openBIM formats, and in particular, it has also been recognized in the latest buildingSMART International Award with a special mention. What I would like to do now is to show you some possible use cases that we have developed by using this technology. And in particular, we will look at IFC models up to the version 4.4, both for buildings and infrastructures, and we will see use cases regarding asset management, asset operation, facility management, and IoT. So let's start by having a look, starting from our platform ASBIM from ACCA Software. This is the BIM user that is looking at an IFC model. In fact, this is a federation of IFC models composed of the architectural, structural, and MEP models. In particular, each object has all its own properties. Now, let's move on to the GIS view and let's see the same model, the same federation, replicated 4 times on the GIS map. Here we can see that we have all the same functionalities with regards to viewing operations. And of course, these are the full detailed models. So if we select objects from the GIS view, we can see all of the properties. Here, similarly to what we have done on the BIM platform, we can use visibility to hide, for example, the architectural and the structural model. And again, the level of detail, both geometrical and from an informational point of view, is completely available on the GIS side. So basically, this is the dynamic connection between GIS and the BIM world. Let's move on to other more complex examples. This one, for example, is the city of Barcelona in Spain. It is composed of 2,000 IFC models for a total of 120 gigabytes. Here we can see that the geometric level of detail is not very much accurate. But this is not a problem. Once we have the models on the GIS view, when we will have more detailed buildings and models for the city, we can substitute the low-level detail ones with some with the more advanced level of detail, like the one that we are looking at in this example. Again, this is a composition of the architectural, structural, and MEP part. So this is the whole Barcelona city, digitalized by using IFC. Now let's move on to another example. This is a city of historical interest in Morocco. Here we can see that we can combine also other input formats, for example, texturized meshes, point clouds, and of course, when available, the IFC model themselves. So here, again, each object has their own properties. This other example, and look that we are going back to the first example that we have shown, this is in order to show you what a dynamic connection between the BIM world and the GIS world can do. In fact, let's say that we move on to the BIM part. So the BIM user wants to update the federation of models. In particular, he is going to add a new model to the federation. So the building that appeared now was not available previously. What happens on the GIS side is that this information is dynamically updated. And so the information is available in real time. And the updating of the model on the GIS side is in real time. Of course, we can combine all the available data from the BIM world and the GIS world and visualize them all together. And moving on to more complex use cases, let's focus, for example, on the asset and the facility management of IFC models, in this case, of a shopping center. Here we have 3 systems that are playing together in real time. There is the BIM platform that is providing the data from the IFC models. There is the GIS platform that is providing the data for the GIS part, and there is a dynamic connection with the facility management system. In fact, we are looking, for example, at some available tickets, open tickets for from the maintenance system. And we can localize such information directly on the entities of the IFC model. Again, all of this data is dynamic and it is not copied over from the different systems. Of course, we can also use other technologies such as the virtual reality in order to, for example, navigate the models. We will see a more complex example later on the use of this technology. But now let's move on to another example. This in particular is the Naples Railway Central Station. It is geolocalized and it is a composition, a federation of 56 IFC models. We can see it geolocalized on the map, and we can see that we can use different kind of maps. And here we can see all of the 56 IFC models federated together and viewed directly on the GIS view. Here we can see how it is possible also to connect external information such as documentation, images, and so on, directly on the entities of the model. Here, for example, we can see how we have attached such information to such entities. Another possible use case is the use of IoT, Internet of Things. Basically, we can, in real time, achieve information and get information from the sensors, for example, for a bridge monitoring use case. In this case, the values are in real time and are basically updating the model to show if the values are basically normal or if there are some problem with the bridge. And so those two systems, the sensor and the BIM model, are interacting each other in real time. Now, if this is useful even for one bridge, since we are on the GIS and on a territorial scale, you can think how this can be useful when you have all of the models of the bridge with all of the sensors together. Moving on, we can see other example. This in particular is a road developed in a buildingSMART Italy project, and it is an IFC 4.3 model that has been developed to show the potential of the new IFC standard schema for the linear infrastructures. And here we are moving on to another example of the new and upcoming IFC 4.4 schema dedicated to tunnel. And this in particular is a first attempt from ACCA software to digitalize the construction of a tunnel. So basically this is the contribution of ACCA software to the IFC 4.4 schema project from buildingSMART. Bridge are another important linear infrastructure that has been affected by the new standard. And again, we can see how we can use other technologies such as virtual reality to navigate and explore BIM models from the GIS view. But IFC models are very different from one from the other. And this, in fact, is a power plant, an IFC model of a power plant with completely different information from the others that we have seen so far. But the fact that it is open data allows, as we will see later on, to do special queries based on this standard format, which is very, very helpful. But it's not all about IFC. There are also other formats, other file formats that are supported by this technology. This, for example, is a football stadium with billions of points, and it is representing a football stadium. And this is another example in which a 50-kilometer railway has been digitalized starting from its cloud point. So we now have both the cloud point and the IFC model put together on the GIS view, and this combined view can be navigated directly. So we have both the cloud point and the IFC model. but the potential use of such combination of technology allows also us to think about the permitting. So for example, when we have the data from the GIS layers and the openBIM data, we can do spatial analysis based on GIS and openBIM data. So for example, let's say that we want, in a certain radius from a certain building, do some kind of data analytics and spatial queries. So for example, here we are looking at the spaces of the building, and we would like to search, for example, for rooms or compartments based on different type of uses, so commercial, offices, residential, and so on. All of this by combining both the GIS and openBIM information. Crucial is the fact that the openBIM information can be dynamically updated, and everything on the GIS side will be updated dynamically accordingly. So, for example, if the BIM user is acting on the openBIM model, for example, by moving objects around or updating the properties of the object, on the GIS side, the user will see all of this that is happening in real time, because the connection between the two systems is dynamic, and there is no exchange, there is no copy of data, but only dynamic exchange. So what we have seen so far is the use of maps, GIS, IFC models, point clouds, spatial analysis on the GIS and the openBIM data, and asset and facility management system talking each other in a dynamic way. This covers basically and can cover all the life cycle of the building, whether it is a linear infrastructure or a classical building. And this is the integration between the GIS world from Esri and the openBIM world from ACCA software. And now let's hear from the RFI team, who will show us the path they are following to implement the Geo Digital Twin within the company.
Thanks, Michelangelo. RFI is the manager of the National Railway Infrastructure. Our main activity consists of maintaining the network in order to allow the railway company to operate safely, make investment for the improvement of the network, railway line and installation, one more than 17,000 kilometers of network, of which 1,500 are HS, employing almost 29,000 people and allowing more than 9,000 trains belonging to the different company to the run every day. In the international field, RFA promotes the integration of the Italian railway infrastructure into the European network. Our strategic project evolve systematically in the different business sectors based on the fundamental principle of asset management for the value creation, referring to asset-centric view, risk-based decision, systemic management, a life cycle. Asset information does not change but increased in the relation to the different phases of the life cycle. It is therefore necessary to have effective tool for digital information management. This is why referred to BIM methodology as a tool for digital information management through open and interoperable standard. In order to have a role as a player in an international context, BIM is implemented in a business process that systematically preside over the entire life cycle and is developed through adopting of the international standard openBIM, application of the standard in RFA process, implementation of the supporting IoT tool, definition of rule, training of research of speeding of the BIM culture.
A digital model that aggregates asset information can support systemic management over the entire life cycle. This approach involves the re-engineering of company processes with the aim of operating a digitalized management of assets on the railway network, integrating the different systems in the company in a logic of synergic corporate and sustainability. Starting from existing assets, it will be possible to create a digital twin in order to support activities on assets and take the opportunity of changing. In terms of new digitalized information management, focus is set at involving the decision-making processes, monitoring of complex systems, the simulation of network activities and corporate communication, defining a clear digital transformation. Strategy for intelligent asset management requires a structured approach coherent with the organization's goals and objectives. Digital twin technology can speed up and optimize this process.
To realize the strategic vision, Rete Ferroviaria Italiana entrusted asset management with the guidance and coordination to set up the strategy shared within the company, coordinating working groups established with specific objectives, and reporting to the BIM committee, chaired by top management, on the progress of activities for the definition of strategic choices. Asset management constitutes the corporate interface to the outwards, participating in working tables with stakeholders, in identifying research and development initiatives. In fact, since 2018, Rete Ferroviaria Italiana is a member of buildingSMART International, participating in the IFC Rail project for the definition of the IFC 443 standards. Therefore, what has been done so far? We are developing the IFC 443 standard in the rail industry, validating it and defining modeling rules and standards. We are implementing an internal training plan about openBIM, involving about 500 participants, with 150 of them already certified. We have established the digital room where BIM methodology can be implemented through the development of specific proof of concept in collaboration with the Italian chapter of buildingSMART International and ACCA software. We have defined and collected BIM objects and models based on Rete Ferroviaria Italiana needs. We are developing company BIM guidelines and standards with the support of Italian chapter of buildingSMART International. Starting next year, future goals include the implementation of corporate guidelines and the dissemination of BIM culture in our company. In the next 3 years, digital information management is expected to be implemented with reference to the company's priority uses, re-engineering processes, defining new rules and training, and using innovative IT tools.
For development of proofs of concept, the available ingredients included the availability of digital models of buildings and installation, linear infrastructures, infrastructure works, library objects, and surveys from MUIF of existing works. The MUIF, Unique Physical Infrastructure Model, project was born in 2017 with the aim of providing a single georeferenced representation of the railway infrastructure, to which the different logical views of the network can be related. Subsequently, this project has been included in the company's business plan that will be concluded with projection to 2032, developing the integration between MUIF and BIM for the information management of physical assets through the use of digital models. Rete Ferroviaria Italiana launched a nationwide campaign of surveys of the national rail network, carried out from 2017 to 2022, to return a 2D vector representation and the physical representation of the infrastructure at different levels of detail, according to the different usage needs. Information from MUIF can be used to define digital models, and new information from new assets in the update digital models can converge in MUIF in order to use updated digital information.
With the view of a continuous updating improvement and with the integration of the best technologies on the market, the MUIF system, based on 2D GIS representation, needs to evolve to a new way of navigating information. Through the integration of GIS and BIM, it is possible to build the Geo Digital Twin. This will allow all digital content to be georeferenced to it, increasing the level of detail of the network and the models by defining a prioritization strategy based on actual company needs. Critical success factors to be considered are production of 3D models, updating of data and models, implementation of technology for use of Geo Digital Twin, and integration with strategic business systems. Based on the current company processes impacted by the implementation of BIM and Geo Digital Twin at RFI, use cases have been carried out to represent the final results of the analysis and the benefits that such technology will bring. Starting with some proof of concepts, the working group identified some use cases scenarios, looking mainly at the interaction of the digital twin with the company IT systems in use at RFA. A video will show you the result of the one-year experiment in RFA.
Thanks, guys. I think that now it is time to have a look at all of what we have said so far in practice. Let's hear and have a look at this success story from RFI, presented by Giovanni Esposito from ACCA Software.
Thank you, Michelangelo. Let's see together the technical results of the project. Rete Ferroviaria Italiana Railway Infrastructure is a complex one to manage. Evolving MUIF 2.0 will ensure an openBIM compliant management. The project proposal starts evolving the current MUIF, which is based on a 2D GIS representation, to a new way to navigate the information already available, adding openBIM 3D model with their information. So we are going to significantly evolve the current representation of the railway infrastructure, starting from a technology known and used inside the RFA. What we are seeing are the resources produced during the previous MUIF survey campaign in the new navigation mode offered by ASBIM Geo Twin. But how is the Geo Digital Twin produced? Let's see it together. The strategy is to start with the production of a basic model of the infrastructure derived directly from existing surveys that can grow over time. This model will be usable alongside the digital resources already available and will give access to all the information that BIM objects naturally bring. The challenge we set was to understand how to systematize all the information at our disposal. Let's take the Benevento Station project as an example, consisting of a structural, architectural and MEP model, and how the technology is already able to support the highest level of detail. We are seeing just how the new MUIF will be able to scale up complexity from the smallest detail, the specific terminal, to the entire world. To increase the consistency of the Geo Digital Twin, we can feed it with other data sources. For example, specific survey campaigns of viaduct serving the network will be incorporated into the system according to the new company standard and guidelines. But the group's various project initiatives overseen by the different companies will also easily find their way into MUIF 2.0. We are seeing here the Irpinia Station project located on the GIS map. Rete Ferroviaria Italiana already has a library of standard BIM objects in AECO openBIM format. These resources will also contribute to update the MUIF. They are organized in a centralized library, and thus, over time, all objects on the network will be able to have their equivalent digital twin and be included within the system. The new navigation experience will be innovative and will enable seamless navigation of all digital resources available, such as 360 photos compared to point cloud and BIM models. Let's look at an example. Here we are looking at a pole spotted in reality on the 360 photo, and on the left side we are instead seeing its equivalent digital twin, both in point cloud and BIM object form. All these digital resources have been released starting from the object that insists in Rete Ferroviaria Italiana's standard library. Even the last technologies, such as the immersive virtual reality, can be used for simulation scenario, as seen here during the driving phase of a train. Let's look at some use cases related to the Geo Digital Twin. The first use case we show is related to video surveillance. We are browsing into the Naples Central Station. Walking through the BIM model of the entire station, we reach to the platforms area, and we can activate video streaming that real-time shows us the situation on the specific platform for security control. Let's look at two more use cases realized on the Benevento station. The first use case looks at the integration of traffic data. MUIF 2.0 will provide access to any piece of information managed with the IT system used in Rete Ferroviaria Italiana from the different locations and routes surveyed within the system. A further possible use of the Geo Digital Twin to support asset management is related to photovoltaic production plants monitoring. First of all, the technology allows all technical and non-technical document resources to be integrated into the MUIF object. We have seen how to access to the technical information attached to the inverter. In addition, we can access and evaluate plant production data individually or historicized thanks to the integration via the IoT paradigm. Other interesting experimentation was conducted with the integration of information that comes from diagnostics. At the first instance, all the elevation data of the line can properly be extracted from its geometry, but the data of the fixed and mobile diagnostics can also be related punctually on the network, such as in that example. Functionalities supporting safety, planning, and cost estimation scenario were imagined for supporting the construction phase in line with 4D and 5D BIM best practices. Directly within the MUIF 2.0, it will be possible to carry out simulation and evaluation on the various ongoing active working sites, consuming the entire available dataset that constitutes the digital twin of the working site. It will be possible to directly navigate the model of the specific work site, and it evolves over time so that all points of interest can be fully assessed. The navigation of this simulation is also ensured through the real-time rendering and immersive virtual reality technology, enabling users to understand better the scenarios. This functionality can also be exploited to support the training of resources that will be on working sites. Another relevant application related to IoT integration concerns the current topic of structural monitoring of bridges and viaducts. The platform, in this sense, will be an active system that will return warnings and graphical feedbacks to the user, supporting decision-making. Let's look at a use case related to RFI mission, namely the maintenance phase of the network. The system we have imagined and implemented in this experimentation has been designed for the maintainer, so that himself can interact bidirectionally with the Rete 2000. In fact, here you are how the end user not only can quickly read data from Rete 2000, but also update it at the same time, using simple interfaces, and thus guarantees the consistency of the information. The maintainer is the main user of this system in our vision and has the active part in digitization process of the infrastructure. In fact, teams on field can digitize new assets that are not available among the digital assets inside the BIM object library, thus bringing them into the Geo Digital Twin. This railway interchange is certainly not a standard object, but it is nevertheless possible to survey it and hook it up to corporate information system by having a well-defined workflow and technology that supports the use case. The MUIF 2.0 Geo Digital Twin does become the central system for the management and maintenance of the entire railway infrastructure. Every piece of data is geolocalized and accessible in real time.
Wonderful, Giovanni. Now back to the RFI team to hear what they have to say about all of this.
The experiment design use that fully fit into the completeness of a BIM dimension. As a 3D BIM, the effort focused on maximizing of use of 3D drawings and available and those that will be received by the suppliers with the goal of making them accessible and searchable. BIM 4 and 5D use case were pertaining to the planning and the costing phase, so as to maximize the return on investment even during the construction phase of the new works. BIM 6D since these are dimensions closely linked to the strategic and activities and the mission of the company. Use cases were geared toward ensuring that all information proceeded to today within different system use would be received or centralized, where applicable within the Geo Digital Twin. BIM 7D, with reference to the sustainability dimension, we declined the use related to the monitoring information from field, useful for increasing the service life of the work. For example, diagnostic, maintenance, efficiency, and the long-term performance of railway infrastructure.
Thanks again to all of you guys. And now let's ask some questions directly to Donatella Fochesato, Asset Management Manager in RFI. First of all, I would like to ask what are the critical factors taken into consideration for the success of the project?
The project scope includes all infrastructure assets of the entire asset lifecycle. Then this project is inclusive, technologically democratic, and scalable in order to maximize the return of investments. First, inclusiveness, intended as the ability to involve the widest number of stakeholders belonging to the entire supply chain, including also not technical profiles. Then, maximization of investment. The issue of technological continuity and the integrability of the new technologies with strategic IT system is considered as one of the key elements for BIM implementation to be truly sustainable for a company of our size. Finally, scalability. The object pursued was to identify the requirements for a technology that, once adopted, would be able to enable the company to build and augment the information assets contained within the Geo Digital Twin, properly managing the massive amount of heterogeneous data.
What added value do you expect from the digitalization of processes and the introduction of BIM in RFI?
The adoption of digital information evolves and improves strategic processes in a synergistic and integrated way to support the supply chain in a secure, transparent, and shared way. We are confident that the digital transformation can improve decision-making process to enable us to provide quickly answers to our stakeholders by creating value from optimized asset management.
Thanks, Donatella. And again, thanks to all our speakers in today's webinar. We hope to have shown you some interesting technology and ideas. We remain at your disposal for any further questions. Thank you very much for your attention.
Well, I'd invite the other speakers and panelists to unmute. We've got a few minutes. Sorry, we are over time, but we figured that given the interest in this webinar, we would just be available for some questions related to that. And maybe I've seen some questions in the chat, and I think they've been answered. Thank you, Michelangelo and Mark. And I guess I had one from the buildingSMART point of view, which is we shared the strategic roadmap at the start of the webinar. How important is it for software vendors, firstly, to have a clear roadmap to support the upcoming standards and services that are being developed, such as IDS, BSTD, and future things like IFC5? How important is it to have a roadmap so you can start to plan your activities in supporting those? And then secondly, how critical is it from an RFI point of view in making sure that the software vendors support those standards so that you can make them available in your assets and on your actual networks?
That was a question to us, Aidan?
Firstly to maybe Mark and Michelangelo, and then maybe RFI could answer the second one, yeah.
Yeah, so as far as a roadmap on IFC implementation, it's really very important. So actually a topic that I organize a group within Esri who are involved with our IFC implementation. And we have many products, and we have different ranges of IFC support, import and export, and some are still on 2.3 and some are up to 4.3. And it's been a topic that we've been kind of bouncing around is that we ourselves need a roadmap. We need to get aligned. We need to make sure that we're working on the things that users are demanding and requesting, which changes over time. So yeah, having that roadmap clearly within our own company and then conveying that at buildingSMART summits, events like this, letting the community know, you know, what direction we're pointing and what they should expect from us is certainly critical for us as a software vendor to be successful.
Yes, and yeah, of course, also for us it is very important to have this strategic roadmap from a BSI well defined, because of course we have our own internal roadmaps, but it is always a pleasure to see that the two are kind of aligned, so we can change the schedule and the priorities on some of our internal projects to try to support better such a roadmap. And being part of the buildingSMART community allows us to be the first experimenters of such new standards and technologies. So of course this translates also to being able to provide in this case RFI or other companies with this new knowledge that we are gaining from the community that then translates into our products. So we see a lot of benefits and again, being aligned in this in the vision of openBIM is of course fundamental for this.
Yeah, and maybe just to ask a question back to our RFI then. So once you get those software vendors supporting that, how important is it to see that integration that you shared between two very active vendors like Esri and ACCA?
Yes. For RFI, it's very important to continue with the experimentation with ACCA software, that is our technological partner. And what we want to do is to increase the geodifferentiation of our assets, and so increase the level of details of our network and define a prioritization strategy based on actual business needs. So we hope to continue with the experimentations on this way.
Great, and thank you for that. And we had quite a lot of questions in the chat, so I don't think we can get to that many. Maybe the one of the things we could wrap up with is, could we do a webinar similar to this for facility management? Could we start to show some other use cases here to develop that? Because ultimately, you know, can the Geo Digital Twin be used in designing? Can it be used operating, maintaining, and managing facilities? So maybe one of the takeaways here is that we need a series of these things to actually show the different phases of a project or an asset.
Yes, of course, we will define this kind of decision and experimentation with them. But now we are just saying what we can do in the near future.
And Esri and Mark, what's on the roadmap really for Esri over the next few months? I know you'll be attending the Valencia summit for BSI, but what's on the roadmap for Esri in terms of furthering this development around IFC and
no, like I mentioned, we have a team of folks in product management, product engineering, certainly in the biz dev side of things, gathering requirements and listening. We have specific developers focusing on tunnels and additional georeferencing. We've recently had some nice little successes where our developers have been able to validate and feedback into the buildingSMART community where some of their exports weren't necessarily working 100%. So it's nice to not just be implementing the software and be able to bring in an IFC file, but work as part of the community and give feedback to other developers who are, in the midst of integrating IFC import capabilities. At the summit in Valencia, really looking forward to running a workshop like we've been talking about, Aidan, on GIS and BIM. So if you're going to be at that summit, definitely put that on your schedule. I don't see a finish line. I see this as being an ongoing effort to continue to integrate the latest IFC capabilities and be involved with the definition and development of IFC, into the future, IFC 5 included.
Yeah, and just to reiterate, I mean, I think we were there in Rome when you invited other sponsors to share their data sets with Esri. So really showing that ability that you can take lots of different sources and work with it, which is really, really good. And I think very encouraging for the whole network. Michelangelo, and also what from ACCA can we expect in the next few months? You've got a lot of support really and a great growing set of products. What else can we expect from you guys?
I could say that so far we have tried to establish the foundation with new tools that try to implement the new standards and the functionalities. Now everything is more, let's say, set in stone. There is the new IFC 4.3 standard, in which we contributed a lot, that we support, and of course also related standards such as BSDD and IDS. So with different tools, we are basically trying to support all the standards provided from the buildingSMART community to try to create these new disruptive workflows. And of course, what can be expected is, of course, continuing the development of such tools, but also see more and more use cases like the one that we have seen today, because we understand that in the end, these are the ones that bring most of the values for the people of the community, because they now start to see really looking at the benefits of all of this, and having the possibility to show all of this with a company such as RFI, it's a pleasure and an honor for us, of course. So I think more and more experimentation and also being able to start to measure the benefits in some way will be to be expected next, of course.
Fantastic. I think, go on, please, RFI. you want to say something? Was that a unmuting? No. Okay. Sorry. I think we're 10 minutes over time. Maybe I'll leave the last comment to RFI. What can the international community do better to make sure that these things are more mainstream and widely adopted? I see a question in here about would like to use this for railway projects. Do we need to use IFC Rail or IFC 4.3? What can the international community do to make sure these things are globally used and adopted and supported? To Elena or Donatella?
Oh, sorry, I have a problem with the audio, so if you can repeat the question, because I couldn't understand. Okay.
What could buildingSMART International do more to make sure that these standards and things that you share are more widely adopted?
Yes, we are experimenting with the IFC 443, and we are adopting the BIS DDA and the ADS, but it's an experimentation that we are carrying out now. So we don't have now a real definition in RFI. So we are experimenting during this year and the standards of buildingSMART, but now we are only adopting for experimentation in our company. That is a very big company, so it's a complex task to perform.
Great. I think sharing these stories is really, really helpful in demonstrating that, which is really important. Okay, I think we would like to conclude there. So I'd like to thank all of our audience for attending. Thank you very much for spending some time. Just to let you know that the access to the recording will be made available to everybody registered. We'll send that across to you. Thank you, Michelangelo, Donatella, Elena, and Mark, for your time, and we look forward to seeing you at a future webinar. Thank you all very much.
Thank you.
Thank you. Goodbye.
Bye-bye. Ciao.